This is Sam Gabriel, and in this video we're going to learn about the env0 self-hosted Kubernetes agents. We're going to learn about their main use case. We're also going to see how to get them deployed and how to deploy a VM in VMware vSphere using env0. Let's get started. So we're going to deploy, as I mentioned, with Terraform to an on-premise environment that's running vSphere. And the main use case or reason for using the self-hosted agents is many big companies and government agencies have some governance requirements and compliance requirements to not allow any third-party application access into their environments. So what the self-hosted agents does, it allows access to the env0 UI from the agent itself within your environment outbound to the SaaS offering. So you don't need to open any firewalls inbound into your environment. Furthermore, you are responsible for the secrets that you're going to use. So the vSphere credentials, for example, in our example today, we're going to store those in AWS Secrets Manager, and you're not going to need to store them in env0's own infrastructure. So let's go ahead and get started and take a look at a workflow that we're going to use in this demo. So we're going to start off in env0's SaaS front end by deploying an environment. So that's where we're going to start. And the self-hosted agent runs in a Kubernetes environment in your own infrastructure. And what it's doing, it's reaching out to the env0 SaaS front end on a regular basis, asking if there are any jobs ready for it to process. So once again, it's reaching out from inside your environment outbound to the SaaS front end. So once it does find a job that needs to provision, it's going to first of all look for any credentials needed. And as I mentioned, we're going to store our vSphere credentials in the AWS Secrets Manager secret store. env0 provides 4 different secret stores that you can utilize, AWS being one of them, Azure Key Vault, GCP's Secrets Manager, and finally HashiCorp Vault's Secrets Manager. And then once we have the credentials stored in the self-hosted agent, or access to these credentials, I should say, so basically your access key, ID, and the secret to access the secret manager will be stored in here as we trigger or create the Helm install. And then the next step is to provision. So the self-hosted agent will have access into your vSphere environment. So networking needs to obviously be set up between where the self-hosted agent is installed and your vSphere environment. In my example, I have the self-hosted agent running inside the vSphere environment inside of a Kubernetes cluster. And finally, you're going to have the logs streamed over to the SaaS front end, so you can see those logs from the self-hosted agent in the UI of env0. That's pretty much it for the workflow. Let's go ahead and jump in and see how we're going to get this all configured. All right, so now let's take a look at the repo that we have here. And we can see that first thing we want to talk about is installing the agents. So we have a Kubernetes environment running, and in this Kubernetes environment, we also have Helm installed. So we are going to run Helm repo add and add the env0 repo here for Helm, and then run the Helm repo update. And finally, the Helm upgrade -- install, which is the install command here. As you can see, it's going to create a namespace called env0 agent and the chart right here. And also we're going to install this in the env0 agent namespace that we just created. And there are 2 values files for variables here that we are going to reference. And finally, we are doing something called post renderer. This post renderer is just needed for my demo today because the Helm chart requires that you run a PVC with specific requirements. The requirements is a read-write many, and the value or the amount of storage it requires is 300 gigs. So I want to override this, so I'm using customize to target the persistent volume claim, as you can see here. And override the read-write many to read-write once, and the 300 gigs to 10 gigs. And you can see the path where we're targeting this: spec access modes and spec resources requests storage. And the shell script that's going to run this is the customize agents shell script that's going to build this and get everything ready for us. And basically that's what we're referencing here with this post renderer. So if you're running this in a production environment, you're not going to need this line here, because you're probably going to be running with the read-write many, and the 10 gig will be too small. You'll probably be good to go with 300 or more. And the reason for the PVC is that this is where you're going to store, or this is where the self-hosted agent is going to store the state files for Terraform. Okay, so let's go ahead and run this command. I have it already running, but I'll show you what this will look like. Very simple Helm install. You can see revision 2 now, and here if I run kubectl get all, should be able to show you what's going on here. I have the main pods is the trigger deployment, 2 trigger deployments here. One is terminating from the previous run and a new one is generated. And then also a proxy deployment. One is terminating and a new one just got generated. And I have a few pods that have run in the past that processed the deployment of some jobs. You will see once we create a new job, you'll see a new pod get generated here. So it's pretty straightforward. You don't have to worry about this once this is running. And the 2 files that I mentioned that are important, the values files here, tecinate values and values.tecinate. These 2 files are found here, and they're sensitive files. They have sensitive variables in them, so I'm not checking them into Git, but I will give you an example of what they look like. The first one, tecinate values, here is the customer values, which I have in Git, so you can take a look. And really this file is a file that you're not going to touch. You're just going to download it directly from env0's dashboard. So pretty straightforward. You're going to go into your dashboard and download this. I'll show you in just a minute. And the second file is this file here called values customer-example.yaml, which is my values.tecinate.yaml. And in here, you can store your access key ID and access key for the Secrets Manager to access Secrets Manager. And it's a base 64 encoded value for the access key ID and again the secret key. So we're going to see that also as we look at Secret Manager, how to generate those. Okay, so now everything is run and we are all set with the agent. Let me just show you where to grab your customer values file. And with that, we're going to jump into our env0 dashboard. And here you want to go into your settings under the projects. So if you go under settings and go under agents. Now, if you haven't talked to env0, the env0 team needs to get you set up so that you can use the self-hosted agents. Once that is available, you can go ahead and download this configuration file. And this configuration file, as I mentioned, is that tecinate values file that you are going to add into your repo and use that with your Helm install command. Okay, so these are the values that allow, as I just showed you, allow you to access, or the agent to access, the front end, the SaaS front end of env0. So you see things like your agent key is tecinate in my case. Other sensitive information I just replaced with XX. As you can see, the AWS access key ID encoded and access key encoded. This is to access the AWS instance where env0 is running, and a few other variables that again will all get populated for you once you download that file. All right, so we have that one set up. Now let's go ahead into our AWS console, and we need to create a policy. And this policy is called, or I call it, env0 Secrets Manager get secret value. So according to the documentation from env0, we are going to be specifying exactly the permissions that we want our agent to have to access the secret manager in AWS. And you can see here's the JSON for this policy. You can see the effect is allow, and the action is secrets manager get secret value, and the resource is anything in secret manager we're going to be able to get the secret value of. The next step after creating this policy is you want to create a user, and this user needs to be created for programmatic use. In this case, I created it called env0 on-prem. Of course, give it whatever name you wish. And when you create it, make sure you add directly the permissions that you just created. As you can see, it's called env0 secret manager get secret value that we just saw. And then head over and create security credentials. So create an access key. You're going to get the access key ID and of course the secret, and it will show only once. So make sure you keep them and base64 encode them. And once you've base64 encoded them, you can go back into your file here and insert them here, so you can run the Helm install command and everything is ready and set to go. All right, this is all good. Now I'd like to show you that my vSphere environment currently doesn't have a VM running. I have a Docker VM that I'm using for other use cases, but you'll see a new VM show up here with the test prefix here. So we'll see that in just a bit once we create our environment. So if this is the first time you're creating a project, go to the projects under organizations and hit the button create new project and give it a name and a description. I've already created one here, so let's get into it. And in here, you can create a new environment directly, but I prefer creating templates. So under the organizations, make sure you create a new template. And once again, create the new template by clicking this button, create new template. I've already created one, so let's go and take a look at the settings for it. So here it is. And this template is a Terraform template type. So you click on Terraform, give it a name, a description, and the Terraform version that we're going to use is 1.3.4. And moving on to the next step is your VCS connection. I'm connecting to gitlab.com because that's where my repo lives, the repo that you saw here. And by the way, the repo has all the Terraform config under this folder called Terraform. You can see my main.tf file where we're provisioning in vSphere. And you can see the virtual machine that we're creating right here, and a bunch of other files like the output where we're going to see the IP address of this machine. And I go into a lot more details in the blog post where this video lives, so you can go in and take a closer look at these files. Okay, so we specified the GitLab username, the GitLab repo right here, and the Terraform folder that we're using is inside of a folder called Terraform, so that's important to specify. Next step is our variables, and this is really important. We can define variables here in the template, or we can define the variables under the organization itself, which is what I did. So under organization itself, you can define the variables here, and as you can see, we're defining the vSphere user, the vSphere vCenter, and vSphere password. And there is a template here to be used with AWS Secret Manager, and you'll find this template in the documentation from env0. And what we're doing here is we're using this keyword SSM : and then the name of the secret that lives in Secret Manager. So if I go over to Secret Manager inside my AWS console, Secrets Manager right here, you'll see that ahead of time I've created secrets that I'm going to use, and these secrets are the vSphere credentials that I just mentioned, and you can see them right here, and they're called env0- and then vSphere password, vSphere user, and vSphere vCenter. That's the IP. So I'm going to show you this one. I'm not going to show you these two, but I will show you this one because it's just an internal IP. So you can see here that it has a secret value that I'm going to reveal. And this secret value is a plain text secret value. It's very important that you use plain text and not key value. Okay, so when you're generating a new secret, make sure you're using plain text and put your secrets in there as plain text. So if you go here and store a new secret, go to other type and then go to the plain text tab and put your secret here like that. Okay, not in the key value pair. Okay, let's cancel out of here. And so these three secrets are the ones that I am referring to over here inside the variables that I will use with Terraform. Now, as you can see, these secrets are not stored right in the in NV0's platform. This is just a reference to where they are so that the agent can go get them from AWS Secret Manager. So once again, we're not storing anything sensitive inside of NV0 itself. All right, so that's great. I have my variables here. So if I go back to my template, I can see that I am calling on these variables directly. They will get populated already here for me, so I'm good to go. You can create these variables in the template themselves. That's completely fine, or in the project variables. Really depends on where you want to use those variables. I prefer to do that at the organization level because I'm going to access this maybe for other projects as well, so I can have them this way globally. Okay, so now we want to look at projects and make sure that you're checking the projects that are going to get associated by this template, or basically this are deployable, that this template deploys are deployable by these projects. Okay, so I have my deploy on vSphere on-prem demo selected. I can unselect this one because I'm not going to use that, and save that. Once this is done, we can go ahead and deploy our environment. So you can go to project environments, create new environment, use the template, and this is our template. So we're going to run this now. Revision, I'm going to use my main branch. You can give it a workspace name. You can add drift detection if you wish. You can have the ability to destroy the environment after a certain amount of time. Let's double check our variables. They are already here, so all looks good. So all we need to do is click run. And once this runs, it's going to basically show you that the deployment will begin shortly. And what happens is now, as you recall, the Kubernetes agent is going to ask if there are any jobs ready so it can start the deployment process. So let's go back to our environment here. Let's run K9S and let's get a look at our pods. You can see some pods running here. These pods kind of race towards which one will take on this particular job. So just be patient while one of those picks up our job here, and it will get started. So you can see that the logs are now streaming already. So we got git clone and so on. So everything is starting. And you can see this is the agent that has picked our job. So if I go in here to take a look at the logs, you can see the logs here. Let's add a timestamp and a toggle wrap. So there aren't a lot of useful information for us in these logs, but it's helpful to see that the job is actually running. Most of the important logs will show up directly in the UI where you can look at them. So we can see that we've cloned it, we've got our working directory, we've loaded our variables, and very soon we're going to run our plan. So we're in the process of running the Terraform plan right now, and then we're going to approve it in just a few seconds. All right, so we're waiting for approval. So plan 1 to add, and the IP is going to show up here at the end. So this all looks good. So let's go ahead and approve. Before we approve, let me just show you that this should pretty much end very soon. The container running here, there we go, stream closed. So now we can see that this container has stopped. There's no other jobs running right now, so we're back waiting for any job to run. So once we approve this, once again, we're going to start to see the jobs racing, or the containers racing to pick up the job again. So one of those will pick it up very shortly. And if we just give it a couple of seconds, this should start running soon. And there we go. We have one container now that's running. We can go in and take a look at our logs. Once again, let's toggle the timestamps and toggle our wrap here. That's good. And let's go back to the UI. All right. So this is continuing to work. Out of curiosity, let's see vSphere, if anything's running here. Not yet. Okay. Okay, I can see now Terraform apply is in progress. So again here, we can see that we're cloning our virtual machine in vSphere. We can see that a VM is starting right here. So we're cloning the template called Ubuntu 2204 template that I actually built with Packer, and it's and saved it here in our templates folder. This one here. So it's actually grabbing this Ubuntu 2204 template, cloning it, getting it all ready to build the VM. As you can see, still creating here in our logs. And of course, our container logs are showing here as well. Okay, almost there. And we're moving along. You can see the machine is almost done here. Let's see what's going on. So we don't have an IP yet, so we're waiting for that. The machine is powered on, reconfigured. That looks good. Still working along. Oh, apply complete. As we can see, here's our output IP address. So that looks very good. And the IP address also shows up here in the vSphere client web portal. And we are done here. You can see our output IP address once again. Everything has been configured. Everything has been built nicely. And if we're curious about our agent is done. The container has successfully closed. The stream here, it's completed. If we go back here to our pods, it's one of the completed pods. As you can see, it's done its job. And we have our new and shiny vSphere VM running, all done via env0. I can log into it right here. And this was based on a Packer image that has Docker already installed. So if you see Docker version, you can see Docker is already installed. I can run Docker run hello world, and all works well. And one last thing, I'll show you the tree. So if I go to CD, the tree utility is also installed, which is part of the installation with Cloud Init that you'll see in the blog post as we're building our main TF file. Okay, so that has successfully completed. We're able to work pretty much the same workflow as if you were running env0 in the SaaS environment, but as you can see, we're talking to it through the front end, and all the work is being done by the agent running in Kubernetes in a closed environment that belongs to your organization. That has nothing to do with env0 itself. env0 is just the front end for all of that. So as we saw, this is very helpful when you have some compliance and governance requirements that you need to adhere to, and this will allow you to do that and run your own secrets on your own environment or infrastructure, and also not open any inbound connections into your environment. I hope this has been useful to you, and I will catch you in another video.